I actually stayed and I didn't do anything a couple of days actually, and I am a bit depressed. Probably the weather. By the way, talking about the weather, here right now is February. Right now is actually 27/02/2023, and 02 it means is February. And before a couple of days, like or weeks, when I was trying this circuit here 1 week ago or something, or maybe 2 weeks, I was trying this OR gate, the IC with the OR gate. Actually, it's this one that I have here. This guy here, if you remember. So this is the OR gate, 7432. And yeah, you can see it probably, no? Yeah, it's the second row here. 74 hashche 32. But hashche 32 is actually MOSFET inside. So I have 10 of this 74 hashche 32 with MOSFET technology inside. And I've ordered 74 LS 32 yesterday. I ordered it, and it all came in a couple of months. 1 month if I'm lucky, 2 months. Normally 3 to 5, even 6 months if I'm having bad luck with the postage here, especially here in Romania, not the international postage. The international postage is doing its job quite excellent, but here in my country, and specifically in my town, they just fuck up everything. They just incompetent. Just no, they don't want to work pretty much, and they just cunts, full of cunts, and they don't want to work, and they are delaying intentionally and with mean purpose. That's the whole reason. And but that's what I was trying to say about this hashche with this MOSFET technology inside and the weather. I was talking with my friend from England, and repeatedly I had this problem before. In other winters when I was doing some electronics, and I was talking with guys, and especially here in winter, and the transition from the winter to the spring, or vice versa from autumn transition to the winter, the air is too wet. The air in summer when it's extremely hot, the air is dry, but in winter the air is wet, and more wet than usual, and the electrostatic builds up very quickly in the winter. And I'm usually forgetful of this quite important, very important thing, and especially for these chips, the electrostatic buildup on my hands, on everything, pretty much on their pins by themselves, just like that. They build up some electrostatic charges there, particles, and when they are connected to something else, they discharge themselves, whatever they do. But they manage to fuck up and destroy those inputs of the chip, and that's the problem with the weather. Now back to the thing that I constructed here. I modified slightly this board. I dragged the outputs of these boards. Modules and this wire that is staying here, and this guy is here that you cannot understand much from them unfortunately, but it's from each of them. Each output pretty much is going to the emitter of each transistor. Top is collector, top pin, middle is base, and an emitter. And for each of them, they are in series. They are in series transistors. Why I'm saying they are in series? Because I put only 1 kilo here. I should have put 10 kilo, and let me actually change it, because that was the original idea. Or, well, not idea, the design of it. I was designing it with 10 kilo there. 1 kilo is a bit, in my opinion, is a bit too harsh, a bit too much. It's stressing a little bit too much. Let's say plus, and there. And it's working absolutely fine with 10 kilo as well. For comparison, you see, this was having red, this is orange here. So I just changed it, and it's absolutely perfectly fine. And what I did here, I put 10 kilo again, 10 kilo per each LED. This is the positive leg of the LED, and that is the negative leg of the LED that is going into the collector. And pretty much with only one transistor, only one resistor here, I connected all their bases in series. That's why I'm saying all these transistors are in series. I don't know how to call them, but because all their bases are in series, like that, like a straight line, connected only one single kilo, 10 kilo here, is opening them up all at once. But because the signal is from here, sometimes it's off, sometimes it's on, is transmitting. So pretty much what I did here is a latch, is like a latch, is opening all the transistors at once with a single contact. One single contact opening 4 other contacts, pretty much. So I'm commanding 4 contacts, 4 outputs, or inputs, whatever, 4 outputs, because these are the outputs. The LEDs, the white LEDs here are the outputs. So 4 outputs that are getting 4 inputs from this board. I'm commanding them with one single contactor, pretty much. And this will be a single switch that will be between on and off for this particular module. But I will make 2 modules. One module like this, exactly like this, for this board. One latch, 4 inputs latch circuit. I'll make it for this board here, and another one exactly the same 4 inputs latch somewhere on the other side, but not on this board in reality, as a final board for this particular board. But the difference between this board and this board, it will be that I will have to put a bit more transistors for this one transistor. So it will have 5 instead of 4 inputs. 4 inputs. This 4 transistors that they are right now here for the inputs, and another fifth transistor for powering this board with the positive, this red wire, the positive rail, because I don't want it to be online or powered all the time. But that one, I don't have any choice but to leave it function, because this is a conversion of what the inputs or the outputs are coming from this guy here. So the signal is coming from here, and this is pretty much like a constant board here. I cannot change it, power it down or up. Well, I can if I really want, but I don't want, because I'm also having the motor direction here, left or right, from this button. And when I'm switching, by the way, this yellow LEDs are designated which chip is switched. So for this LED that is lit right now, that chip is on, is activated right now. And for this LED here, that chip is activated. You see, and the sense is also changed. So left to right or right to left. And pretty much this is what I will do. I was very, very hard thinking on making a contactor between these boards from jumpers. I know. Let me show you 1 second. Here they are, this kind of jumpers, if you know what I mean. They are not jumpers, they are called pins. I know, but I have 1,000 of them, probably. I don't know how many, but I have a ton of them. Brand new, of course. I also have scrapped, and but that's not the point. And I was thinking to use jumpers on them and switch with a single module, with a single, like a plug and play. Plug in one jumper like that, and here another jumper like that. And it's a very good idea, but it's a very good idea actually. And it's smaller than this. It's way more smaller. But I was curious if this will work. I wasn't sure. I was thinking, I was having multiple ideas. I was thinking if I have to command multiple boards, like this two that I have here, but another one that I will probably build in the future, the third one. And this is a bit more easy, kind of easy to command from one single click and step through each module of input latches, like I did here, for multiple input latches, I call them. And I was, of course, with a decade counter. Actually, with one of these guys, 4070, with a decade counter, and I will switch between those three with one single button, like pack, and I will switch from this to that board, and then coming again, rotated again to the first, and so on. That's interesting. It's interesting, and I like it. I like the idea. But I was considering a couple of days. I stayed and think about this problem, and I was seriously thinking on using those pins and jumpers, because I don't really want a fast or convenient way of switching. In this particular case, I don't really care the switching, how it goes, I mean how fast I can switch it, if it's from one button or if I have to unplug from one side and plug it in the other side. It's really, it doesn't matter. The convenience, how convenient it is. It's actually with jumpers is more secure. I know for sure this board will transmit another other one by mistake or something, by mistakenly pressing the button. So that's why that was the idea. And probably if I'm upset for some reason on this kind of combination this kind of circuit board that I built here, and is working for the moment, if I'm upset for some reason for it, I will switch back to this version with the pins and jumpers, which is very, very solid. It's very solid, and it doesn't matter how convenient it is to switch it back and forth, because I'm switching pretty much the way of the signal. Pretty much I'm switching from this wave signal to this full step drive signal, two different signals. And that's the whole idea. As you can observe already, probably you did observe that the LEDs here, I will slow it even more, but it is slow enough. Right now it's very slow. Even more slower, like that. You see, it's very, very slow. So all these LEDs that you see here are not actually corresponding with the LEDs that I'm having here, with the signal that I'm, for each open LED that I have on this board, that one will stay off. So if this is on, that is off. So this segment is inverse of this segment. What this means, it means that it will not switch the sense of the motor from left to right or from right to left. No, it's not that. It will only change the numbering. So if I'm starting from here on this board, if I'm starting from 1, 2, 3, 4, here instead of starting from 1, it will start from 3, 4, and then 1, 2, 3, 4. But the sense of the motor, the signal sense is the same. It will count in this direction also, but a little bit it's like a delay. Not delay. It's like a jump. It's like a little bit of a mismatch and it really doesn't matter. Because really doesn't matter. Trust me on that. Even if it's right now at this moment with all this circuit, what is doing here, this is actually an OR gate. This here is a XOR gate, but in conjunction with this 4 transistors that I have there, they are corresponding exactly. These outputs here are corresponding exactly with that what I'm sending from this board. As you can see, I don't know which one. The last one is corresponding to the green one here. So the last here is corresponding to the green one there, and the other one is following. And this is actually in the same. This how it should have been from the beginning, when I started this project here, I originally imagined I will have a definite OR gate here, but it turned out it transformed itself because I had to make it work, and it transformed itself into a XOR gate. The entire per each module, you can see there are 4 modules, and per each module is a XOR gate. I didn't even know until I made a comparison in the simulator. I compare this circuit that I have one module here. I compare it with the OR gate circuit, and when I see the OR gate was behaving in the same line with that, and this was inverse of that, then I realized this must be a XOR gate, but I didn't think of it in the beginning to make it a XOR. It just transformed itself by wiring everything and make it work. But this configuration that I have, this entire configuration that I have here, is an OR gate and following exactly that output that I have there, which is convenient in a sense, but I really don't care. It doesn't really matter. It doesn't really matter what if it's an XOR or if it's a OR. Simple OR gate doesn't matter, because all that matters is the signal to be 2 by 2 and the sense, the direction. And if I'm switching from this, you'll see it will go back in that direction. Everything will go back from that direction, you see? And pretty much, I don't know what to say more than this. I'm happy. I'm very happy with this thing because it's actionable. I can command it from only one click. And let me show you what click that I am. I was. You see, if I'm putting my finger here, I'm actually. So it's not connected to anything. I'm just touching the resistor or here. Doesn't matter where. So my finger is opening all these 4 bases of the transistor, all them 4. They are NPN transistors. I forget to mention this. BC, BC548 are how much? 200 milliamps, and they are up to 30 volts. I don't care. 500 milliwatts, I will never go there. But yeah, for this, you see, if I'm touching the resistor, it will continue the program. It will open all the bases of the transistor, and everything will work fine. So if I really want a touch method, which is very interesting as well, only to touch and see if it's working, that's not bad either. And if I'm connecting it to the positive here, it's I don't have to keep my finger there to always touching it. So pretty much this is it about this part. I will start to make the board for this module, for this multiple input latch thingy, which is my idea. I didn't find it. I didn't search it on Google. I just thought of it, and it's very simple. It's that simple. These were more complicated, and I had to actually search for a way of. But now by repeating this procedure, it is really stuck in my memory. I know exactly what I have to make without searching anymore. But it's good to search for how to make a logic gate from discrete components, and on Google, and you will find quite a few versions only with transistors, without the diodes, with the diodes like I'm having here. These 2 main versions you will find for any gate, possible logic gate. You will find these 2 versions only with transistors and not diodes, and the other version with the diodes like I'm having it here, and possibly 1 transistor or 2 transistor or no transistor at all, only with the diodes and some resistors there. Depends on what you find, but there are there. So that's what I did for this. But for this, it's that simple. I was very, very curious if it will work with 1 single resistor for all of them, because that's the idea. That's my intention, to drive all the transistors at once. I'm opening all at once, and they are staying open even if the signal is low. The transistor is still open. If the signal is low and nothing is passing through the transistor, no current, is still open. It's just doing the job of saying open. And that's it. It's pretty much like a latch. It's not saying off and not permitting a current passing through it. It's staying always on and permitting current through it. Pretty much this is it. Thank you very much. I hope you like it, and also leave a like, also leave a comment. Why not? I'm not asking for money. Everything I make is free as usual, and as my art is, my art is and was always free. And I did a lot of free art for a lot of people, and they were happy. Some they were cunts, but that's another story. But yeah, thank you very much, and see you later. Bye bye. Bye bye from Romania, from your favorite artist electronist here. Bye bye. Yes, I didn't had the intention to make this movie with Proteus circuit here, but I said, well, it's good for completion. It's good to have a complete, everything to make it good from start to end. What I did here is exactly what I did on the breadboard there. Actually, this simulation, what I'm doing here, I'm doing it after I did it on the breadboard. Usually, I'm doing it here in the simulator, and then I'm building it on breadboard. This is the the beginning, the middle, and the end steps. I'm starting with simulation in Proteus, and then on the breadboard, and then on the final cardboard that I'm building, pretty much. Especially for these complicated circuits that I'm having here. But for smaller circuits, I'm not making these steps all the time. So pretty much is doing exactly what you've seen there on the breadboard. Let's play it actually to see it. Let me switch here. When I'm switching, this switch is switching between wave mode and full step mode. And also these LEDs, you see here, this LED and these LEDs are switching accordingly when I'm switching one or the other. And they have 10 kilo, the LED, they're supposed to be a bright, super bright LEDs. And here is the 1 kilo. Here in the Proteus is not working exactly like in reality. So I had to lower the value. In reality, it worked either with 1 kilo or with 10 kilo on their common basis that I have. But here in Proteus, it doesn't want to work with 10 kilo on their basis. I don't know why, but it doesn't. So 1 kilo it is here in Proteus. And the same here as well, because I have the two modules already. I built them. And here on the top, this is actually the wave mode. Is this compartment here? Let me actually use my drawing board here. This compartment, including all these four display LEDs, I call them. So this these four LEDs here are only to display what is going on this four bus lines, signal lines here. But the magic is done by these two converters pretty much. And this is the wave. And this is what we have here, the wave mode on the top when I'm selecting it on the top. And when I'm selecting it on the bottom is powering these transistors, and also it is powering with plus 5 volts. Let me actually show you. You see, I'm getting this 5 volts from here to this transistor, and it's actually powering all this module, the entire module. Let me show you. If I'm playing it right now, yeah, it's a bit of error there. But you see, if it's the top one selected, the bottom one is staying off. It's staying off. Nothing is actually only the signal lines. The signal is coming into these diodes here, but that's it. But the modules themselves are not powered. You know, these transistors are not powered. The modules are not powered until I switch here. And when I'm switching down, that switch is actually powering this little module here. That is actually letting power through this is powering this module, this entire full module here that I have pretty much. And this from each output from these modules is transmitting to these lines here through these transistors, through these lines. And let me actually, I put here 220 ohms resistors because without it, it didn't work. It didn't, actually it worked, but it didn't display the LEDs. These LEDs here were not lit. The current was not that high through this. This transistor is behaving like a resistor. I don't know what kind of value of resistor is here in the simulator. In reality, I bet my ass it will not be the case. But here in the simulator, I have to bypass it. Pretty much, I'm bypassing it. I'm feeding a little bit more. I'm helping with a little bit more current through this very low resistance value here, and I change it many times until I've seen it work, and it's pretty much on the edge here between staying lit all the time, doesn't matter what I'm switching here, or staying off all the time, it doesn't matter what I'm switching there. So that's on the edge. I had to tweak it very, very closely to bleed some current and to actually work it here in the simulator, not in reality. In reality, it will work fine with only one transistor, and the current will power this entire module because it's not that hungry for current. But here in the simulator is something else, a little bit different, but not that much. But that's my solution here to actually see these LEDs work. And let's play it. And it is selected. Let's select it the first mode, the wave mode, and it should be exactly like we are seeing here, 1 by 1, not 2 by 2. And we can see it here, 1 by 1, 5, 7, 10, and 12. 6 and 11 are always on, so don't get misled by them. 5, 7, 10, and 12 are 1 by 1. You see, and when I'm switching, and also the motor is counting, kind of fast or slowly. I don't know if it's fast or slowly. I think it's faster. I don't know. When I'm switching the switch here to the other mode, we are seeing here 2 by 2. You see, 2 by 2, 2 inputs at once, pretty much. This is slower, I think, but there is a little bit of difference. Not that much because the speed is not the speed is not that great here in the simulator. Because if I'm turning up the speed from, where are you? It is a potentiometer somewhere. This guy here. So if it will give me some nasty errors, program errors. And if I'm keeping it at very low speed, also this potentiometer at very low value, less than 35%, I put a note here. And if it's counting, a bit more slowly than usual, I will not get any kind of error. So the motor is spinning a little bit slowly. But it's good to have it like this. We can count together. So 0, 1, 2, 3 here in the middle. No, it's fucked up. Of course it's fucked up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9. So okay, so let's see if I'm switching the switch. We will see that 6, 7, 8, 9, 10. It's a bit faster. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I don't know. But there is a little bit of speed difference between them. I believe it's slower here in this full step mode because they are two coils at once, it should be slower, but more force, more torque. While when here in this mode, the wave mode, is only one signal per line, and it's kind of faster. I don't know. Well, we will see in the reality how it will do exactly. And but what is important is that it is working also here in the simulator. Very cool, very good. And I've included everything actually right here. I've included these two LEDs, the signal to signal which is wave mode, which is full step mode, and potentially that's a very important thing to add another module. Like here I'm having the wave module. Let's see, here I'm having the wave module, not you, and here I'm having the full step module, and probably a half step module drive. Half step drive module somewhere in the future. I will it's a question mark if I will do it or not, but this will be linked there as well to another small module like this with latch small latch transistors like this. And very important is that it can be scaled down or up. I can add other module, and if I have to switch between all three of them, I will use, like I said already, a 4017, and I will instead here, as you can see, is wired master reset. This pin MR, this MR pin is master reset and is linked to Q4 here. But in my case, if I want to switch between three of the modes, I will have to link it to Q3 here, and it will switch from 0 to 1 to 2 and then back to 0, and pretty much that's it. And I will clock it. I will put a button on the clock, and when I will press that button, click, 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 it will switch these modes and then reset to 0. That's the plan, and that's the scalability. How bigger I can make it, and more awesome. you know, yeah, I really like it. I really like it so far. I like the results. I like good results. We will see. So yeah, this is it. Thank you very much. See you later.